In order to find the arc length in a circle, we need to think of it as the fraction of the circumference. So in a circle, we have something called the circumference, which is the distance around the circle. And we typically have the formula that the circumference equals 2 pi r, or since we know that 2 times the radius is the diameter, it's just pi times diameter. But we'll just, for the sake of this, use 2 pi r. So I have some radius, and I'm going to plug that value in, and it's going to give me the circumference. And that's, again, the distance around the circle, typically in units, inches, feet, centimeters, whatnot. Kind of like perimeter for a circle. Now, we want to talk about a fraction. So, let's look at a new circle. Let's think, well, what if I didn't want to go all the way around the circle? What if I wanted to go halfway? Well, I know that the circle all the way around is 360 degrees, so halfway would be 180 degrees of the arc. So if I had a radius drawn, and then another one, and that formed a straight line, that would be 180 degrees. It would be half the circle, it would be half the circumference, it would be the length. Okay, let's do another one. Let's say 1/4 of the circle. Well, if I said out of 360, 1/4, notice I would multiply the 4 by 90. So I can multiply the 1 by 90. That would be 90 degrees. So 90 degrees would be 1/4 of the circle. Now let's think of another one. How about 1/6? That's another common one you may see. 1/6. Well, if it's out of 360 degrees, because 360 is all the way around the circle, 1/6, well, let's see, 6 times 60 is 360. So 60 degrees would be, about right there, would be the length for 1/6 of the circle. And we can kind of get the idea that different fractions work. So let's pick more common fractions maybe. Or maybe even degrees. Let's start there. What if I had 120 degrees of the 360? So maybe in this problem I'm now looking at an arc where I have 120 degrees, and I want to see how far that length would be. Well, 120 of 360 reduces to actually be 1/3. So that would be 1/3 of the distance around the circle. Now let's think for a second. If that would be 120, wouldn't this be 240? Because it is 360. And so if that was 240, that fraction would be 2/3, which makes sense because 2/3 and 1/3 would equal the whole thing. And if I looked at that 240, I'd be now looking at the length around that portion of the circle. So we're talking about these fractions using this degree measurement to help us take the circumference. So we can then take that fraction and compare it to the circumference of the circle. So maybe we go back to our original problem here, and we have 120 degrees. And let's pick a radius. Say it's 5 inches. So I know the circumference is going to be 2 pi r, and I'm going to take a fraction, so that's the angle over 360 times circumference. Our angle is 120 over 360 times 2 pi times 5. 120 over 360 becomes 1/3 times 10 pi. And if we stop right here, we actually can answer two different questions in this problem. What the circumference is. The circumference is 10 pi. What fraction do we want of it? We want 1/3. So when we take that 1/3 of 10 pi, we're not a space here, we'll move up, we get 10 pi over 3, which is actually 3 1/3 pi. We could then make it 3.3 repeating. You can multiply it out from there, but that's going to be 10 pi over 3 inches, or you could say 3 1/3 pi inches. Now, last thing we're going to look at here is, all right, what if I wanted to find the length where I have 135 degrees and 20 inches is my radius? So, to find the length, all the length is a fraction times circumference. Fraction is going to be the angle over 360, circumference is 2 pi r. So I got 135 over 360 times 2 pi times 20. Well, I get 40 pi as circumference, so that's the whole thing. And then 135 and 360, I can actually divide them both by 45, and I get 3/8. This turns out to be 15 pi, because 3/8 of 40 is 15. And you could think of it as 40 and 8 have a common factor of 8, so you can divide, it becomes 3 times 5. So that is my length right here. That is how far it is around the circle. Well, let's look down at our last one here. So what if now 15 pi was my length, and I wanted to find what the radius would be? So maybe this is a scenario where I have two different circles, two different radiuses for all we know, two different measurements, but I want to find when the length would be the same. So we're still using the parts we know. It's going to be the length equals the angle over 360 times 2 pi r. Length is 15 pi. The angle is 90 over 360 times 2 pi r. The first thing I would like to do in this problem is I notice I have pi on both sides, so I can divide both sides by pi. Takes care of that. 90 over 360 becomes 1/4. So let's get rid of that. Make it 1/4. But 1/4 times 2 actually becomes 1/2. So I'm left with here is 15 equals 1/2 r. Well, using the reciprocal, or multiplying both sides by 2, I get 30 equals r, which tells me that in order to have the same length, arc length of 15 pi, my other circle needs to have a radius of 30 inches.